Good morning, everybody. I see everyone joining on. My name is Kenesha of Encryption Consulting. We're going to give everyone about a minute or so just to join and get settled in, and then we will start our webinar. Thank you again for joining, and let us know where you're joining in from in the comment section. All right, I think we can get started now. I do see people still trickling in, but we'll go ahead and start now. Good morning again, everybody. My name is Kenesha Williams. Welcome to the Understanding Confidential Computing, a guide to securing your cloud workloads. I want to thank everyone for joining. Hoping you all are doing great. Again, my name is Kenesha Williams. I'm the marketing manager with Encryption Consulting. And today we have with us Yee of Anjuna. I just want to quickly give an overview of Encryption Consulting before handing it over to Aaron. Encryption Consulting is an established data protection consulting market leader. We focus on the areas of PKI, HSM, encryption, tokenization, and data masking. More than 100 corporations of the Fortune 500 have sought our help in protecting their sensitive data and solving the most complex problems. We are considered one of the leaders in consulting, planning, and advising of product selection. Having said that, I'm happy to introduce our speaker, Aaron Yee. Aaron is the head of product marketing at Anjuna and has a wealth of experience in the enterprise security industry. Prior to his role at Anjuna, Aaron led product marketing for the lifecycle management product at Okta, where he successfully launched products such as Universal Directory and Workflows. Previously, Aaron worked as an identity and access management consultant in DC, where he provided innovative solutions to civilian and DoD agencies for their most complex identity management challenges. Aaron holds a BA in computer science from Brown University and an MBA from the University of Virginia. In his free time, he enjoys reading, sailing, snowboarding, tinkering with cars, and passionately cheering on his favorite football team, the 49ers. That's a bit about Aaron. And before I hand it over to Aaron, please be sure to share your questions in the Q&A bar for Aaron after our presentation. And also, please note that this session is recorded. And without further ado, I'll hand it over to Aaron. Aaron, thank you.
Great. Thank you for the warm welcome, Kenesha. And for all the attendees, thank you for joining. Anjuna Security is a confidential computing company, but this presentation is not meant to be a product pitch. It's just meant to be an introduction to confidential computing. So I hope this is helpful in aiding your understanding. So with that, let's go ahead and get started. As you all know, the cloud has been instrumental over the past decade and a half in shaping the way we do business. And many organizations obviously see benefits in it, right? They can get better economics when they use the cloud. They get a stronger set of capabilities and a higher level of flexibility. And so the cloud is increasingly becoming the preferred location for hosting business applications for enterprises. And, the cloud is well suited for, being a platform for enterprises to migrate their existing legacy IT workloads to. It also provides a really good platform to host data and advanced analytics. And it provides a good platform for hosting new digital workloads and also collaboration platforms. So there's a lot of benefit in using the cloud, as I'm sure you're well aware. However, while over 90% of enterprises worldwide are using cloud computing in some sort of capacity, the vast majority of businesses are still keeping their business critical applications on premises. And these business critical applications represent their crown jewels, right? That enterprises still don't entrust to the cloud. And if you ask leaders why they haven't migrated these applications, the answers are always invariably the same, right? It comes down to security, compliance, data privacy, and sovereignty. And those are the most commonly mentioned blockers of moving to the cloud. And when you talk to tech leaders, they prefer to use data centers because they have full control over their infrastructure and the security within those data centers. And the infrastructure is not shared with anyone else. And this provides a sense of security as the organization is solely responsible for everything, including down in the bottom, all the infrastructure, all the compute infrastructure, and all the applications up on top that they run and all the data that they process. So on-premises security, seems pretty straightforward when it's in the data center, but by no means is it easy. Now, when enterprises move to the cloud, they have to deal with what's known as the shared responsibility model. And in this model, the cloud providers own and operate the infrastructure down below in gray, and the customers own and manage the applications and the data and possibly the secrets up in blue above. Now, the crucial challenge in this shared responsibility model is protecting the compute layer. And the issue here is that anyone who can access the compute layer, including internal threats and external threats, can move up and access the things in blue. So they can access your code, your data, and your secrets and exfiltrate them, right? The cloud is open to the world, and if you configure it incorrectly, suddenly this becomes a really, really large risk. And when you get all your secrets and your data and your code exfiltrated in clear text, that's the first level of danger, data exposure. Now, if the attacker breaches the compute layer and then gains access to the secrets above, such as keys or tokens, they can carry out secondary attacks by decrypting what you thought was safe, right? They can decrypt your encrypted data, which can lead to devastating consequences. So this is the second level of danger when compute is essentially breached. This slide shows a list of recent hacks that made headlines. And all of these organizations faced devastating breaches. And once attackers bypassed traditional security controls, whether it was through phishing, whether it was through malware, if they maybe somehow brute force their way in, they were able to move laterally and then conduct broader, more complex attacks with severe outcomes. So the message is, once the attackers are in, the traditional security mechanisms don't stop attackers as they move from system to system. Now, you as an enterprise, you're probably following best practices and you're implementing a layered security approach, which is highly recommended. But it's important to note that even with a layered security approach, you can't completely prevent attacks, even with the best practices in place, such as protecting the perimeter, verifying identities as the first line of defense, using vulnerability detection tools, and using encryption to secure data at rest and in transit. There's a long-standing flaw in computing where the compute layer is unprotected once someone gains root access. Specifically, the core of the problem is that data in use, which is data that's being processed, has always been unencrypted because the processor needs data to be in clear text in order to make sense of it. And this allows hackers to extract clear text data from memory. Fortunately, there's a significant advancement in data security called confidential computing. And this is what we're talking about today. Confidential computing processors, these are modern processors delivered by Intel and AMD. They deliver hardware level isolation, right? Which makes this technology extremely secure. And essentially you can take your workloads and make them completely isolated, completely secure from anyone who accesses the machine, and possibly also from any other processes that run on that machine. And so confidential computing at its core guarantees these properties. The first is data confidentiality. And this means that attackers cannot view the data being processed, even if they gain access to the machine or compute layer. Second, data integrity. The attackers cannot modify your data, even if they gain access to the machine or compute layer. And then finally, code integrity. Attackers cannot modify your executing code to do malicious things, even if they gain access to the machine or compute layer. So this is pretty powerful. Now, confidential computing offers a solution to the trifecta of data security by providing encryption for data in use, right? So this is data that's being processed. And we can now ensure that all three states of data, which are data at rest, like something that's in a file system or storage, data in transit, which is data going over the network, and then data in use are covered by encryption. And it's crucial to understand that data is initially created and processed in use before it is either stored in a folder or file system on the left-hand side, or transmitted over a network on the right-hand side. So it's essential to protect data in use to maintain its security as it transitions to the other two states. And while confidential computing is primarily designed to safeguard data in use, which is in the middle, a solution like Anjuna's can extend this protection to the other two states of data. And I'll talk about that more on the next slide. And this is why I've drawn two arrows on this diagram and put padlocks on all three states of data. Now, before confidential computing became available, the machine was the smallest entity you could trust. And this included the entire operating system, device drivers, and other running processes. And this resulted in a very large circle of trust and numerous potential vulnerabilities. However, if you secure your data in use using confidential computing, which is what we're depicting in green, and then you pass that protected data to an untrusted operating system in red, and then you ask that operating system to encrypt your data before storing it on the file system or transmitting it over the network, it raises security concerns because the operating system in red could be compromised. So in green, if you decrypt that trusted data that you are processing on confidential computing environments, and then you pass it to an untrusted operating system, and then you ask that OS to encrypt it at rest and in transit, doesn't seem very secure. So with confidential computing, you can trust the code or trust the application and not the machine, which results in a much smaller circle of trust. And that's depicted over in the green. And the mechanisms of confidential computing allow for the creation of a unique identity for your code or your application. And essentially how that works is you can get a hash or a measurement of your application, which acts as a checksum. And then you can have the hardware, the CPU, sign it with a key that's embedded in the processor. And that can be verified by external parties. And this allows others to verify two critical aspects about your application. The first is others can verify that your application is not running any rogue code. So essentially it's unmodified and it is the application you think it's running. And then second, others can verify that your application is running on secure and trusted hardware. And this is really important to establishing trust with external systems, like for instance, a key management system. And so with confidential computing, you can now trust the application on the left-hand side, trust the code and not the machine. And as shown in the diagram, once you do that, you can bring the endpoint of encryption, such as your encryption keys for data at rest, or for TLS keys, to encrypt your data in transit. You can bring that into the trust circle of your application or your secure enclave. And this provides greater assurance that your data is secure and protected. Now, confidential computing is more than just another data security tool, right? It's not just Anjuna who's providing this technology. The major chip makers shown here and the leading cloud providers and various tech titans in the industry are investing heavily in confidential computing because they believe in its promise to really transform data security as well as the cloud. Now, confidential computing, what can you do with it? It enables many use cases, and we're seeing traction from enterprises in areas such as cloud transformation, secrets protection, sensitive data privacy, multi-party computation, and compliance. And these use cases enable enterprises to better protect their data, comply with regulations, and scale their apps with confidence. And so let's go through each of these really quickly. Cloud transformation seems pretty straightforward, but a lot of regulated organizations are blocked from moving their critical core business applications to the cloud because of concerns over data privacy and security, possibly even because of compliance. Confidential computing gives them a way to protect their data in a way that they no longer have to worry about these concerns. Secrets protection. If you're running a key management system or vault on premises, you can now move it to the cloud securely and have that key management system run in the confines of a secure environment and essentially distribute the keys to the applications that need them in a scalable way using the cloud. And you can also protect the recipients, which are the applications that need those keys. So if anyone breaches or compromises the machines on which the applications run or on which the KMS system runs, they won't be able to, memory scrape and find the data from that machine. Sensitive data privacy. This is important to obviously a lot of regulated industries, but also to independent software vendors who want to perhaps create a more differentiated offering or a privacy enhanced version of their products to differentiate themselves and maybe address new markets. And then multi-party computations, it's a fairly new idea. We see this in organizations who need to collaborate and combine data in order to achieve some shared goal. So for instance, a bank, in order to fight money laundering, cannot do it by itself. It needs to actually combine data with multiple banks, possibly even competitors. And they need to look at financial transactions to see if there are patterns that could lead to identifying money laundering. But of course, no bank's going to do that with a competitor without guaranteeing its own privacy. So confidential computing allows the analysis to be done in an isolated environment whereby no member bank's privacy or transactions or data is actually exposed to any other member bank who wants to participate in this multi-party model. And then of course, compliance, right? Increasingly, we're seeing regulations now mention or recommend the use of confidential computing to protect data in use. Now, confidential computing is a significant advancement in chip technology. So it starts down at the hardware and it protects data in use. But to fully leverage its capabilities and make it easily accessible to enterprises, a software layer is necessary. And if you look at this diagram, this is essentially the Anjuna pitch, but I'm not going to pitch the Anjuna product. This is what we offer. The software layer must be able to help enterprises in these ways. It must be able to support a variety of applications. Organizations might have traditional applications or cloud native ones written in different programming languages, among other things. And second, this software layer must eliminate any barriers that might arise when attempting to safeguard apps with this confidential computing technology. A lot of these technologies require refactoring and recoding of existing applications, which can be time consuming and costly for businesses. So a good software layer should provide a runtime environment that allows an application to run on top of it without being modified. And that the result of that is the application gets protected with this technology. And the runtime environment should include encryption, and it should enable the application to, this is a new phrase for most people, but attest or claim in layman's terms that the application and the environment is unmodified and it's running on secure hardware. And then lastly, the software layer should be able to cater to organizations that embrace a multi-cloud strategy. So various cloud providers offer different confidential computing solutions. There's no standard, right? So it's challenging for organizations to move from cloud to cloud and have their apps be fully protected. So the software layer must bridge this gap and then present a unified solution, regardless of which cloud the customer prefers to use. Now, here's some use cases. These are some real ones that we've helped customers with. We had a multinational bank that was failing to adequately serve its customers who wanted to, the customers wanted to check their balances. They wanted to bank online, using mobile apps, using the web experiences. But behind that application was a mainframe. And the mainframe couldn't scale to address all of these customers' needs, especially after COVID-19 happened. More and more customers started to bank online. And the mainframe just couldn't keep up with the growing number of transaction requests, which resulted in really poor customer experiences. Customers were often waiting multiple seconds or possibly even minutes for their banks to load their transaction data. Additionally, the banks were leasing these mainframes, and with the increasing number of transactions, it was becoming more and more expensive because these mainframes, when they're leased, they charge on a per transaction basis. And the organization wanted to scale out this customer front end in the cloud, but they were being blocked by their security teams who said, it's not entirely safe. And so with Anjuna, the bank was able to protect and scale out this front end securely while running in the cloud. And the result of that was, well, the bank was able to service its customers. The latency times dropped, which was great. And the customers had a much better customer experience. And also the cost dropped for the bank because they essentially built a caching layer in front of their mainframe. Another customer that Anjuna helped out, this is a more modern blockchain company. They have a key signing service for their customers that runs in multiple clouds. And this key signing service essentially takes the customer keys, splits them into shards, and then reassembles them to actually sign a transaction. They had initially built a confidential computing solution in one cloud and realized we have to extend this service to another cloud because customers are demanding that the service runs in another cloud. But having had experience building out confidential computing for that first application, they realized it was a major undertaking that they didn't want to repeat when moving their application to the second cloud. So using Anjuna, they were able to get much quicker time to value while delivering the security that they needed. So confidential computing powered by Anjuna has the potential to really enable organizations to do more than just keep their data secure and private. With Anjuna, enterprises can confidently move to the cloud, benefit from cloud economics, and better comply with regulations. But beyond that, confidential computing offers a new way of keeping data private and secure, which opens up new possibilities for collaboration and new business models that were not possible before. So, we talked about multi-party compute as a previous example. That's now enabled by confidential computing that will allow businesses to build new business models, new ways of creating revenue, et cetera. So at this time, we'd like to open up the floor for Q&A. I'd be happy to answer them. Any questions? Please put them into the Q&A box.
Thank you for that, Aaron. We appreciate the presentation. I do see, as Aaron did say, there are a couple of ways you can add questions. You can do in the chat. There's also the panel at the bottom there where the Q&A box is. Please feel free to share your questions there. I do have a couple here, Aaron, that I will read for you. The first one I'm seeing is without confidential computing, is data encrypted at rest and in transit unsafe?
I wouldn't say it's completely unsafe, but I would say it is vulnerable if someone's able to breach the compute layer. So as we talked about before, if someone's able to breach the compute layer and they're able to scrape the memory, which they can do pretty easily with basic commands, they can pull down encryption keys from memory. And once they have those encryption keys, they can then decrypt your encrypted data at rest that you thought was safe. And they can also potentially, unwind or decrypt TLS traffic, which could be pretty devastating.
Wow, and I didn't even know that, so that's really good to know. Thank you for that. I do have another question here. What level of encryption is available for confidential computing?
Oh, could you clarify that question? What level of encryption is available for confidential computing?
Yes, this was a question that just came in. What level of encryption is available for confidential computing?
The different chipsets implement like different, I believe, different levels of encryption. I would have to look into it. So, for instance, if you look at Intel SGX or AMD's SEV technologies, you'd be able to find the specs for the level of encryption.
Great, thank you for that. And another question that I see here is, do you consider embedding fully homomorphic encryption algorithm to achieve secure computation?
It's a great question. So, for others on the line, homomorphic encryption is another way of protecting data in use by keeping data entirely encrypted, and the processor can process encrypted data. But it's the problem that we found with homomorphic encryption is performance. It's performance. It's oftentimes 1,000 times to 1,000,000 times slower than confidential computing. And then the second problem, or the second challenge that we've noticed, is that homomorphic encryption doesn't provide the general purpose capabilities that confidential computing does. So, moving things to the cloud, for instance, would be, difficult. You'd have to identify your apps and rework them so that all data is encrypted and processed in an encrypted state. And that's a lot of rework. So I would say confidential computing is more flexible for most organizations, especially if they want to use it now, today, to protect data use.
Got it. More flexible. Well, that makes sense. And another question that came in is NIST or FISMA? Question.
Right. So these are guidelines, NIST frameworks. We would have to dig into the NIST frameworks to see if they mention recommendations of confidential computing.
Got it. And another question here is encryption driven by the chipset selected? Who can make the selection of a chipset?
Right. So there are major providers of these chipsets that provide confidential computing. Obviously, Intel and AMD are the major chip providers, but also AWS makes its own silicon, and they have a solution that runs across multiple chipsets, providing confidential computing. NVIDIA is providing GPUs that have this confidential computing capability also. So it's the manufacturers who drive the encryption level, and then the cloud providers, they choose which chipsets to offer in their cloud instances. So, for instance, Azure has embraced both AMD as well as Intel chipsets. GCP runs on AMD SEV chipsets, etc.
Okay, that makes sense. Thank you for that, Aaron. And I guess I'll throw in another question here. How does confidential computing protect data when it is in use? And what types of data can it protect?
Okay, good question. So, how does it actually work? The chips offer the ability to create these secure enclaves or these trusted execution environments. And it's basically a carved out portion of the chip that, it's isolated. So other processes can't peer into it. And once you have this, isolated portion of the chipset, you have this key that's embedded in the processor. And that key then encrypts any memory that the application or the process needs. So the memory space is also encrypted, and it's only decrypted when it's pulled into this secure isolated portion of the chipset for decryption. And that protects you obviously against people who hype the hypervisors. So it protects you against the cloud providers. Certain chipsets also protect you against other processes once someone's able to get access to the compute layer. And what's the data that it can protect? It's all data that would essentially be in memory. So it would be your application code. It would be the data that it processes, and it would also be, the secrets and the keys that the applications used to access other applications.
Thank you for that, Aaron. And another question I have here is, what are some of the challenges that businesses may face when implementing confidential computing, and how can they overcome them?
Yeah, I would say the biggest challenges are there's no standard way of implementing confidential computing because the different chipsets offer slightly different capabilities. Enterprises are often left wondering, okay, which one do I know to, how do I select, the different, among the different chipset offerings, or even among the different cloud offerings, when they just want the protection, right? Possibly across multiple clouds. So I think that's a big challenge, and that's one that Anjuna solves by providing this unified platform. So we kind of abstract away the difficulties and the nuances of the different chipsets and clouds, and we give a uniform interface or solution to enterprise, so they can easily move from cloud to cloud. Another challenge is, I think many organizations, enterprises, think they can do it themselves and implement confidential computing, but that requires a substantial amount of rework to their applications. They have to refactor it, typically splitting it into trusted and untrusted parts, and then building the integrations to their key management systems so that their applications can get the secrets that they need. So that's just a lot of engineering work that most enterprises want to avoid.
Yeah, not doing it on your own. I hear that. And so I have another, I guess the last one here is, can you give us an example of how confidential computing can be used in a real world scenario?
Right. So I think right now we're seeing a lot of traction in organizations that are just facing friction when trying to move to the cloud. We think this is an outdated need, but it still very much remains for regulated enterprises, and for large enterprises too, who aren't regulated. They don't feel safe moving workloads to the cloud. Confidential computing unblocks that concern. Some real world examples are like what we mentioned with that bank earlier. Some other customers that we have want to use AI and ML models in the cloud. They want to protect those valuable AI and ML models, and they also want to protect the data that they crunch. And they need the scale of the cloud to do that. Data centers are just too limiting. So confidential computing allows them to have this cloud scalability to do AI and ML on their data.
Okay, got it. I do believe I'm just checking through our Q&A to see if any other questions are coming in, Aaron. Seems like we're wrapping up a little bit. I guess we'll kind of close out here. And before we do close, I want to say thank you so much, Aaron, for being part of this and giving this this webinar. If you see on the screen here, we do have some resources that you guys can jump in on and further your learning, further your community. As you can see, we do have our community that we're building here. So we'll send that link out actually in our email follow-up, which you'll also get a link to this webinar, the recording, and you can learn more about PKI assessments. And Juna has a few resources and demos that you can check out. And having said that, if you have any other questions, about what you heard here that Aaron has presented, please feel free to reach out to Aaron. I'm sure his inbox is open for you to connect with him, and stay in touch with all of us. Aaron, do you have any closing remarks for everyone before
Absolutely. First of all, I want to thank all the attendees for joining. And what I want to articulate is confidential computing, it really represents a significant leap forward in data security and privacy. It's not just another data security tool. This is fundamental. You've seen the support from all the major tech titans. And this technology will change not just security, but also the way enterprises use the cloud. And I think it will become the standard way we compute. So definitely look into it and check out the resources. If you think about in the past how TLS transformed the way we protect data in transit and how that opened up the doors for secure computing online, I think this has the potential to to be at that scale.
Thank you so much for that, Aaron. And thank you everybody for joining us who's at the webinar. We hope you had a great time and we will definitely be in touch. And I guess that's all for now. See you at our next webinar. We have another one coming up on Monday. Protect your keys with Entrust. So please do look into your emails and sign up for that one. It's going to be another great webinar. And thank you to Anjuna and Aaron for being part of this experience. Thank you, Aaron. Thank you, everyone. Have a great rest of your day.
My pleasure. Thank you, everyone.
Bye.